Hello, friends. My name is Professor Mastermind. I'm a math tutor by profession. I've always been intrigued with the concept of how time contracts. When we travel closer to the speed of light, somehow time is set to contract. Um, I would like to explain it the way I have understood it. I do not profess to be an authority in the subject, but I thought it would perhaps help a layperson or an interested school kid to, to understand this idea and be amazed at this great idea. This will also kindle some interest in some young minds, and perhaps they would want to explore more. The idea is actually based on two main concepts. One is called the principle of relativity. So the principle of relativity, as you can see, let me underline it for you here. This says that the laws of physics do not change on inertial frames. Now, what are inertial frames? These are non-accelerating frames, or frames which travel with a uniform speed. The speed of light is same for all observers. What does that mean? Generally, there is some relativity involved in observation. For example, consider these two race cars here shown and imagine that they are moving in this direction. This is moving, say, at a speed of 140 kilometer per hour, and this is moving at a speed of 120 kilometer per hour, both in the same direction. Imagine that there is an observer here, we'll call him O, and he is observing another his friend F, we'll call him F. So O is observing F. According to O, F is moving in this direction with a speed of 140 minus 120, that is 20 kilometer per hour. So this is something relative. On the other hand, imagine if O is moving in the speed of light, c. So O is moving this way and friend is moving this way, both with the speed of light. Now when O actually observes F, O would feel that F is actually moving with only speed of c. So in this case, the c does not get added. So logically we would expect the speed to be c plus c, 2c. However, this is not the case. This because the speed of light is same for all observers. So it can never exceed c. So the special theory of relativity is actually based on these two main postulates. Now let's consider we have, say, a spacecraft shown here, and assume that this spacecraft is got a certain mirror. So let me try to draw the spacecraft here, something like this, and assume that this is observing area and it's got, say, a mirror here, and it has got a detector here. Assume that a ray of light comes, hits this and goes back. So let's take a case that the total distance traveled is d and the time taken is just 1 second. So the speed would be distance upon 1. This is the speed in which the light would have traveled. On the other hand, now let us take a case that the spacecraft is actually moving from point A to point B with a certain speed closer to the speed of light, say at a speed of 0.5 c. Now the observer again is here and the receiver is here. So this, in the same way, the signal is sent from here, but it hits here, and by the time the signal comes down, the spacecraft has already reached here. So the total distance traveled now is capital D. Because by the time the signal reaches here, the spacecraft has already moved in this direction. So now the speed c is capital D upon t. But the speed of light cannot change. So this would only mean that d by 1 is equal to capital D upon capital T. This means that t is d upon d. As you can see, this is greater than 1. Now this would mean that more time has elapsed inside the spacecraft. More time has elapsed. So faster the spacecraft moves, slower the time passes for that person inside the spacecraft. Faster the spacecraft moves, slower the time passes for the person inside the spacecraft. So this would mean that one day in a spacecraft, one day in a spacecraft would mean several years for a person on stationary Earth. So what does that finally help us to conclude? That time is different for different observers. This is the conclusion, and this was called the special theory of relativity. The person who thought of this was Albert Einstein in 1905. So Einstein came up with this idea in 1905, and he called it the special theory of relativity, simply because it was valid only for non-accelerating frames. Later he took another 10 years and went on to develop the general theory of relativity. Now this has got a lot of consequences. The consequences mainly are the length contraction, which we'll talk about later in another video. Also time dilation, and finally the classic equation E is equal to mc square. So fine, this is how I would I would have understood this idea. Thanks for watching. I really hope that you all understood the main idea. Goodbye and good luck, everybody.